Hello, so today we're going to be looking at this rather funky looking question up here. They say that y equals the r sinh of the square root of x, and they want us to differentiate this. To do that, I'm going to say that sinh of y is therefore equal to root x, of course, because the r sinh is the inverse sinh. Therefore, I'm going to do d by d. Well, I would do d by dx, but sinh y is actually a function of y, and so I'm going to say d by dy sinh y multiplied by dy by dx. That's going to be the d by dx of root x. Now this right hand side is quite easy because x, well, the square root of x is x to the 1/2, so this is d by dx of x to the 1/2, and as we know in the power rule, you multiply down by the power, so 1/2 x, and then subtract 1 from that power like this. That's 1 over 2 x to the minus 1/2, which is 1 over 2 times the square root of x. Now on the left hand side, d by dy of sinh y, well, sinh y is this guy right here, which we should know, and then I'm going to do d by dy of that. Well, d by dy of e to the y is e to the y, minus dy by dy of e to the negative y is negative e to the negative y over 2, which of course is e to the y plus e to the negative y over 2, which is cosh of y. Now, coming back to my equation above, I've got cosh of y multiplied by dy by dx is equal to 1 over 2 root x. Therefore, dy by dx is equal to 1 over 2 root x times the cosh of y. Now, is there a better way of me writing this? I ideally want only x's on the right hand side, but I've still got this cosh of y thing. Now, I know that root x from here is equal to the sinh of y. So can I make cosh into a sinh type expression? Well, recall that cosh squared y minus sinh squared y equals 1, because if we do e to the y plus e to the negative y over, well, half of that, all squared, subtract a half of e to the y minus e to the negative y, all squared, that's going to give us 1/4, and then in our brackets we're going to get e to the 2y plus 2 plus e to the negative 2y, subtract e to the 2y, and then this times that times 2 is going to be subtract 2 plus e to the negative 2y. Put our brackets around those, and that's going to be 1/4, that's e to the 2y minus e to the 2y, they cancel, e to the negative 2y, subtract e to the negative 2y, they cancel, so 1/4 times 2 plus 2 is equal to, of course, 1. This is just proving this identity just here, if you've not seen that before. Now, this means that the sinh squared of y is going to be equal to 1 minus, sorry, no it's not, it's going to be equal to the cosh squared y minus 1, or cosh squared y is equal to sinh squared y plus 1, which we know that sinh squared y is equal to root x, so that's going to be root x squared plus 1, which is simply x plus 1. Therefore, cosh of y is going to be the square root of x plus 1, like so. Now, coming back to our equation up above, we had dy by dx is equal to 1 over 2 root x cosh y. That's going to be 1 over dy by dx equals 1 over 2 root x times root x plus 1, so I'm just going to write it like this, all under the same square root umbrella. So that is our final answer for dy by dx. Now, coming back to the question we had up here, we want to hence or otherwise, which just means hence, find the integral from 1/4 to 4 of 1 over root x plus 1 dx. So let's get started. Now, of course, let's call it I. I is our integral from 1/4 to 4 of 1 over, it was x x+1 dx. Now, let me just check I've written that correctly. I have. There's no other numbers anywhere. So this is our integral. Now what they probably want to do is for us to use the expression given above. Now we had that root x was equal to the sinh of y, right? That's the thing up there. If this differentiated basically gives this thing right here, then this integrated should give something resembling this thing right here. That's why it's probably a useful substitution to use. If this is true, then of course, as we had before, x is equal to sinh squared of y. Then let's just put that into this expression right here. We also had x+1, didn't we? It was equal to cosh squared of y. So let's use all of this and see what we get. So let me leave the bounds for the time being. That's going to be 1 over, well, root x, of course, is the sinh of y. So I'm just going to write sinh of y multiplied by root x+1 is equal to, well, root cosh squared y, which is cosh y, multiplied by dx. Well, now I need to figure out what dx is. So if I do or in fact, if I take this equation right here, I'm going to say multiply up by dx and multiply up by the denominator over here. That's going to be 2 root x plus 1 dy is equal to dx. Now 2 root x plus 1 is simply 2 root x is sinh y, multiplied by root x plus 1 is cosh y, dy equals dx. Now that's pretty useful, I think, because instead of writing dx here, I'm going to write 2 multiplied by sinh y multiplied by cosh y dy. Now a few things happen. These guys will cancel out, and these guys will cancel out, and so my integral is now simply from 2 dy. But I need to know what bounds, because I've ignored this bit so far, haven't I? So I need to know what is going to go here. Well, let's start to figure that out. When x is equal to 4, we need to know what is y. Well, obviously the root x is equal to 2, and sinh y therefore equals root x equals 2. Now sinh y is e to the y minus e to the negative y over 2 equals 2. Therefore e to the y minus 4 minus e to the negative y equals 0. Therefore e to the 2y minus 4 e to the y minus 1 equals 0. So using the quadratic formula now, we're going to get e to the y is equal to negative b, which is 4, plus or minus b squared, which is 16, minus 4 times a times c, over 2a, which is 4 plus or minus the square root of, well, that's 16 minus 4 times minus 1, which is plus 4, which is plus square root of 20 over 2, which is square root of 20, of course, is 4 times 5, so square root of 4 is 2 times root 5. That's going to be 4 plus or minus 2 root 5 over 2, which is 2 plus or minus root 5. So this is e to the y. Therefore, y is going to be the natural logarithm of 2 plus or minus root 5. Root 5 is greater than 2, so 2 minus root 5 would be less than 0, which means we'd be doing a natural logarithm of a negative thing. We can't have that, and so this has to be a positive natural logarithm just in here. There we go. Okay, so this is one of our answers, which is going to go when x is 4, so this was the top bound, right? This is going to be natural log 2 plus root 5 in there. And what about when x was equal to a quarter? So let's take x equals a quarter, therefore root x is equal to a half, which is equal to sinh of y. And let's do the whole thing over again. Let's say that e to the y minus e to the negative y over 2 equals 1/2. Therefore, multiply by 2 and subtract it to the other side. I'm going to get e to the y minus 1 minus e to the negative y equals 0. So e to the 2y minus e to the y minus 1 equals 0. Now this looks a little bit familiar to some of you, I'm sure, but using the, again, quadratic formula, we're going to get e to the y equals negative b, which in this case is plus 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c, that's a multiply, over 2 times 1, which is 1 plus or minus the root 5 over 2. That is actually equal to the golden ratio, which is phi. Now again, you can't do a natural log of a negative thing, so y is going to be the natural log of 1 plus root 5 over 2, like this. And so that's going to go in our integral up here. That's going to be the natural log of 1 plus root 5 over 2, a bit like that. Okay, now this integral is eminently soluble, so let's take it down here. Of course, the integral of 2 dy is just equal to 2y plus c, but when we're integrating within some bounds, we don't need the plus c. So that's 1 plus root 5 over 2, and that's ln of 2 plus root 5, just here. So that's going to be evaluated between ln 2 plus root 5 and ln 1 plus root 5 over 2, which is going to be 2 times the top thing, 2 ln 2 plus root 5, minus 2 ln 1 plus root 5 over 2, which is equal to, using our natural logarithm laws, that's going to be the natural log of 2 plus root 5 squared, because this 2 goes to become a power inside, divided by, because this negative means the argument of this function, divide by the argument of this function, that's 1 plus root 5 over 2 squared. The over 2 squared becomes over 4, and if it's a fraction within a fraction, that 4 is going to migrate to the top, and so that's going to become the natural log of 4 times this thing. So 2 plus root 5 squared is going to be 4, plus 2 times root 5, which is 4 root 5, plus root 5 squared is 5, divided by the bottom thing, which is going to be, ignore this 2 because we've already migrated that to the top, that's going to be 1 plus 2 root 5 plus 5, which is now the natural log of, multiplied through by this 4, and 4 plus 5 is 9, so that's going to be 36 plus 16 root 5 over 6 plus 2 root 5. These don't go nicely into one another, but we can always multiply by the conjugate of the bottom, which is going to be 6 minus 2 root 5 and 6 minus 2 root 5 in order to rationalise that denominator. Now that's going to become the natural log of, well, let's start with the bottom. 6 times 6 is 36. Plus 2 root 5 times 6 minus 2 root 5 times 6 is going to cancel out, which is the point of doing this. And then we've got plus 2 times negative 2 is negative 4. Root 5 times root 5 is 5, so minus 20, like so. Then 36 times 6 is 216. 36 times minus 2 root 5 is minus 72 root 5. Plus 6 times root 5 is plus 96 root 5. And then we've got minus 2 times 16 is 32, root 5 times root 5 is 5. So 32 times 5 is 160, and it's negative, because we have a positive times a negative, like this. There we go, and that's going to be the natural log of 216 minus 160 is going to be 56. Minus 72 plus 96 is plus 24. Root 5 over, that's going to be 16 on the denominator. Can we simplify this? Yes, we can. I believe we can divide everything by 4, or 8 actually. Let's divide everything by 8. That's going to be ln of, what's a funky L? ln of 7 plus 3 root 5 over 2. That is our final answer for this problem up here, which was, just to remind us, the integral from 1/4 to 4 of 1 over the square root of x, x plus 1. They wanted it in the form ln a plus b root 5 over 2. We have it ln of, what was it we had again? It was 7 plus 3 root 5 over 2, which is exactly the form that they wanted. 7 plus 3 root 5 over 2. Therefore, a is 7, b is 3, and 2 is 2. There we go. Hope that made sense, and I will see you in the next one. Thank you for watching.